And thank you all for coming. This is actually our favorite place. It's certainly my favorite place. I always have everything I can at Story and Song. I will say that Donna and Mark have over the years been tremendously supportive of our community in many ways, and we do appreciate that. We also appreciate your attendance, your being here, your support in general in everything we do, and all contributions that you have sent. I get the duty of introducing Joyce. Actually, I think everybody in the room already knows Joyce. But a few facts that you may not know. Joyce has a way of getting around, right? She's a retired 8th grade environmental science teacher. She's also a trained NOAA Climate Steward Educator, and that's the foundation of this. Last year she was involved in training the kids for the Duval Regional and Florida State High School Envirothon competition. That is the largest environmental science competition at the high school level in the country. And that's also what she did in Maryland at Frederick High School. She coached the team there. So that's important. Another thing that she did, she was on the Middletown, Maryland Sustainability Committee. And that's of particular interest to us because those of us in Conserve Nassau would like for the city and the county to have such committees and to have wonderful people in the community serving on those committees. While serving on that committee, she was awarded the 2020 Individual Frederick County Sustainability Award for her community work. No surprise, really, but I'm sure. She's a member of the Citizens Climate Lobby, the Jacksonville chapter. We all know she volunteers for absolutely everything. She has been our treasurer for Conserve Nassau. She's been involved in every single thing we have done since day one. She's been highly involved in Invader Raiders with Kathy Russell, the University of Florida Horseshoe Crab tagging at Fort Clinch, Sea Turtle Nest Patrol in the state parks, also shorebird nest stewarding and surveys in the state parks and in at Main Beach and Fort Clinch as well. She is perennially optimistic, these are her words. She is perennially optimistic that humans can change course and choose to live sustainably to preserve our fragile ecosystems for all the world's future children. And if Joyce Tuten has anything to do with it, I'm sure it will be successful.
This is literally, actually this could make me a little verklempt, this is literally why I'm here. Because, when they talk about changes in 2030, 2050, I'll still be alive, I think, in 2050. But turn of the century, I will be dead. They might be alive. They would be very old. They might be alive. If they have children, my grandchildren would be alive. And the world's grandchildren would be alive. And I truly think we have a moral duty to leave this world in a place that's useful for them. And especially for the poorest who don't have the time and energy to be here and learn and speak and act. Which is why actually I'm super hopeful that many of the world's churches will pick up this mantle as a moral duty. And they are beginning to. I love this picture. This is Earthrise from the Apollo mission. The year I was born, actually, 1968. We are a rock floating in space. The resources on this planet are not limitless. And we need to keep that in mind. I'm looking at my notes because I hate when I forget to say things. One thing for sure, I think we need to do is have a growth mindset. Climate change has been studied for decades, but they are continually learning more. And somebody who listens to this recording 10 years from now will say, I can't believe she didn't say blank, because we don't know about blank yet. Like we have to continue to learn new things and have new understandings, and not be afraid to make mistakes as we try to solve this problem. So this is my outline. I have my phone there with the clock. I'm from New York, New Jersey. I speak fast. I'm going to try to go super fast. The beginning, part 1, is a lot of graphs, some chemistry, some physics. Woohoo! Yay, science! I love that part. Part 2 is awful. Part 2 is awful. It's frightening. It's scary. It's real. It's put your head in the sand and pretend it's not happening. I am going to try to blow through it as fast as possible because it's so awful. And not get stuck on slides and explaining things too much. And then so we can get to solutions. My goal, we have to be out of here, lights out at 7:30. It's 6:11. So my goal is to finish by 7 so that we can have enough time for questions before we get out of here. Which brings me to one other thing. I first gave this talk 5 years ago when I was working, volunteering on our sustainability committee. And every time I would give the talk, people in the audience would say, hey, could you come to my church? Could you come to our city commission? Could you come to my school? And I kept giving the talk more. So if your group, because I know you all are, you're here, you're involved, you're engaged, you're active in other groups. If your group wants me to give this talk to them in some form, longer or shorter, I would love to. And I do it for free, and I do it because I feel it has to be done. So let's talk. So here we go. We ready? The science? Yay? Okay. So greenhouse effect. It's what it looks like. So sun's energy gets through the glass and can't get back out, and the greenhouse warms up, right? Exactly what happens in your car, right? Your car warms up. Exactly why you park in the shade, so that the sun can't get in, which is why they should plant more trees in parking lots, right? And you even roll the window down so the heat can actually get out. You don't want the greenhouse effect in your car, right? So that's what the greenhouse effect is. We have a greenhouse effect on this planet, which is awesome. We'd be in super big trouble if our atmosphere was not capable of creating a greenhouse effect. If we didn't have an atmosphere that could trap some heat, we'd be a frozen rock, and life as we know it couldn't exist. So we have to have a greenhouse effect, so it's awesome. I love this slide from NOAA because it's sorta correct. I mean, it's like totally not to scale, but I have to say that because it bothers me. But I love these waves because they're sorta right. So the way the greenhouse effect works on our planet is the Earth is sending super high energy, really short little wavelengths, if you remember your physics, right? The electromagnetic waves, the shorter the wavelength, the bit more energy. So super high energy waves are coming to the planet. And they have so much energy, they bust right through the atmosphere and hit the Earth. And they hit everything. They hit your car, they hit your skin, they hit the ocean, they hit the sand, they hit the road, they hit everything. And everything absorbs a little bit of that energy, right? We know it does because things get warmer. Lizards sit in the sun to get some of that energy, right? Well, when things absorb a little bit of that energy, they don't absorb it all. They re-emit a fair amount of it back towards space. But when they re-emit it, it has less energy because they use some of the energy. So less energy is going back towards space. And that energy are these red waves. Longer wavelength, less energy, it's infrared radiation. So this infrared radiation is radiating back towards space. It can't all get out. Some of the gases in our atmosphere function like the glass in a greenhouse. They're able to chemically, physically actually, react with the infrared radiation, and they trap the infrared radiation, and they don't let it all out. Some of it can get out, but not all of it. Some of it gets trapped. And that's why we are able to have a warm climate, because we can trap some of this heat. And what has happened is, for 10,000 years or so, the balance of what was coming in and going out was pretty steady, was extremely steady. But in the last 150 years since the Industrial Revolution, the balance is out of whack. Hence, we have a problem, which we will get to. So these greenhouse gases, what are they exactly? This is a big gross slide. Don't look at it all. The most important thing on this slide is carbon dioxide. It is the most important greenhouse gas. So all of these gases function as greenhouse gases in our atmosphere. Some of them are man-made, some of them occur naturally, some of them are both. So carbon dioxide is our most important greenhouse gas. Methane is also a very important greenhouse gas. And all of them are increasing in the atmosphere. So when they talk about carbon emissions, they're talking mostly about carbon dioxide, but they're also talking about methane, because they both have carbon in them, right? But they're really talking about all emissions. Sometimes you'll see emissions written on a graph as CO2 with a little e or a little EQ in terms of equivalent. They try to set some kind of an equivalency, almost like money, foreign money exchange or something. So they set carbon dioxide as having a warming potential of 1, and then they compare the rest. So carbon dioxide is the most abundant greenhouse gas in the atmosphere, which is why it's the one we talk about the most, and it's the one increasing so much. And it lives in our atmosphere for a really long time, which is why it's such a long-term problem. Methane is a very, very serious short-term problem. Methane is also increasing in our atmosphere, and it's has much stronger warming ability. The others I really am not going to talk about. One of these days I'm thinking I'm going to do a full class with Amelia Lifelong Learning. Are they the ones that do a class? Yeah, like a full class on climate science. Anyway, so they're all increasing. This is methane, this is nitrous oxide, this is sulfur hexafluoride. They're all going up. These are all going up because of humans. This is carbon dioxide. This is carbon dioxide measured in Hawaii at the Mauna Loa station just since the 60s when they started measuring there. It's going up. In fact, it's going up so much, it has gone up 50%. The amount of carbon dioxide in the atmosphere has gone up 50% since the Industrial Revolution. And here's the rub. There's not that much carbon dioxide in the atmosphere. I'll go back. It just recently hit a new record of 417 parts per million. So for every million molecules in the atmosphere, only 400, for every 1 million, only 417 of them are carbon dioxide. So it's not a big part of the atmosphere. The vast majority of our atmosphere is nitrogen gas that is very inert and does nothing. You breathe it in and you breathe it right back out. Thank goodness we have a lot of oxygen. And a tiny sliver of our atmosphere is all the other stuff. But just like, I think of it like hot sauce, it only takes a drop to change your soup or something. And that's what's the deal with carbon dioxide. It's not that prevalent in the atmosphere, but it's going up significantly, 50% higher. Y'all remember carbon? Yes, carbon is your friend. Number 6 on the periodic table. Pretty much everything in your body contains carbon except for the water. It's found in fats, proteins, carbohydrates, everything. We are carbon-based life, right? Pretty much everything living, plant and animal, has tremendous amounts of carbon in it. And the carbon cycle is not taught in 3rd grade like the water cycle, because it's more complicated, because it's carbon moving around in different molecules. So the carbon might be in the protein of a deer muscle, but then it gets eaten by a coyote, and now it's in the protein of the coyote muscle, and then the coyote poops, and now it's in the poop, and then a fungus, degrades it, and now it's in the fungus, and then it gets back into the earth, and it cycles around. And so the carbon cycle moves all around in different molecules, sometimes as a solid, sometimes as a liquid, sometimes up in the atmosphere as a gas. It was hanging around, doing its thing. All living animals breathe it out, right? When you eat food, you breathe out carbon dioxide. When plants do photosynthesis, they use carbon dioxide to perform photosynthesis. And so this cycle is going around just fine for about 10,000 years, very, very even, until Industrial Revolution. And we found a whole bunch of carbon buried in the earth. And we're like, cool, this stuff is awesome. And what is this stuff? This is the fossilized remains of plants, mostly algae. Hundreds of millions of years of fossilization. So we have oil, which is mostly octane. That's what they make our gasoline out of. We have natural gas, which is mostly methane, and coal, which is mostly carbon. This is a pretty simplified chemical reaction, but the bottom line is, if you take a carbon compound and burn it, I don't care what it is, wood, a hamburger you just ate, if you burn anything, and burning is combustion in the presence of oxygen, if you burn a carbon-containing product, you will produce carbon dioxide gas. It will be given off. It's super simple. And the more of this we burn, the more carbon dioxide we produce. The worst one on the list is coal, because the amount of energy you get out per gram of coal is much lower, so you have to burn more coal to get the same amount of energy out. And I mean, honestly, we can't hate on these fossil fuels that much because, look, life's pretty great, right? We're not living in caves, waking up looking for food and water. Fossil fuels have produced unbelievable amounts of energy and have powered our modern life. The problem is we need to stop burning them. We need to stop producing so much carbon dioxide. We need to find an alternative source of energy. And we need to do it fast. And we need to do it almost to zero. And we need to have an urgency about it. This is my favorite graph of the day. It's also fairly complicated, and it's not that dark. It's a little bit hard to see, isn't it? So it's time on the bottom here, Industrial Revolution right here, present day right here, and the gray, it's got two y-axes. The gray line is carbon dioxide measured over here, right? So carbon dioxide since the Industrial Revolution has been going up, 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 up. It used to hover around 280 parts per million. Now it sits at around 417 parts per million. And notice, if you remember your math, right? When graphs go, and when they start to go steeper, that means acceleration, right? So we are not only producing more carbon dioxide, the rate of production is accelerating. We are producing more every year. Now, what's going on with the bars? That's temperature. So what they did was, this is not a measure of temperature, this is a measure of temperature anomaly. So they took an average of the world's temperature from 1880 to present. What was the average global temperature? And let's call that 0. And that's what this baseline center line here is, almost like a horizon. And then they said, okay, now every single year, what was the average temperature that year? Was it a below average cold year, or was it an above average warm year? So you can see what's happening. If you are over 40, which looks like most of you are, you have never lived, if you are under 40, thank you. If you are under 40, you have never lived in a below average cold year. So there are a couple of you that are under 40. You have lived in nothing but above average warm years. I was born in 68, so I had a couple of below average cold years. If you're a lot older than me, you remember some significantly below average colder years. Yeah, the world is warming, and carbon emissions are to blame. This is a 10-second video from NOAA. This is just the Septembers. It's the same exact graph, but just the Septembers. Because if you remember, or if you heard in the news, June, July, August, September were hottest ever on record. We had the hottest ever record summer, warm summer on the globe, not just here. So this is a little depressing to watch. It'll start with the temperature and industrial revolution, and then boom. It's literally off the charts. You might have seen it because it made the news. It made sort of regular news, not just the news I pay attention to. That NOAA had to literally change the graph and add another bar. This past September, global, this is a global average, was so off the charts warm, they needed a new graph. And this frightens me, because the Paris Agreement said we need to stay below 1.5 degrees Celsius. Yeah, it's disturbing. 2023 is already declared the hottest year on record, even though it's not done yet, because it just was so hot the last 5 months in a row. And of course here we had significant heat also. By the way, I went back and I looked, Yulee had 71 days above 90 this summer, which means we were close to 90 on many days. Those of you who have been here a long time, I mean, I know my in-laws, when they were here forever, they used to always come in September, they would come back. Then they started switching to October because September wasn't cool enough anymore. Yeah, that's not pleasant. I mean, we're rich. We'll just go inside our air conditioning, or we'll just go to Maine for the summer or something, right? But what do the poor do? They suffer. Heat impacts are among the greatest impacts of climate change. So this warming, this greenhouse effect, these greenhouse gases that we're increasing, that they are causing the warming. That's what global warming is. The warming of everything, the air, the land, the sea. Global warming is being caused by excess greenhouse gases in our atmosphere. And in turn, global warming is causing the climate to change. Okay? So they're not interchangeable words. They're directly tied together, but they're not interchangeable. So obviously temperature patterns are changing, precipitation patterns are changing, humidity levels are changing, wind patterns are changing, and all these changes are having follow-on impacts in all different other areas. Okay, so we ready? We ready for all those other impacts? Actually, before we go there, yeah, 2 more slides. Before we go there, how much warming are we going to have? It depends. It literally depends on the choices that we make particularly in the next 10 years, but even in the next 20 years. And most of you are not going to die in the next 10 years, right? So you have an ability to act in the next 10 years. The Paris Agreement, the world agreed to stay below 2 degrees Celsius, but really said we need to make an effort to stay below 1.5. And we are not on track to do that, by the way. We are more in one of these center tracks. But we still can bend the curve. And the fact of the matter is, every bit of reduction helps. It's kind of like, the weight gain we're all having between Thanksgiving and Christmas, right? Every pound you don't gain is better in January, right? And that's true here. Every bit of emissions we reduce will be a fraction of a degree less warming, will be a less impact somewhere in the world. Ooh, I have goosebumps. So when are we going to bend the curve? Gosh, sorry, it's overwhelming to me. I actually have climate anxiety sometimes. I have to. It's part of the reason why I have to go out and do stuff, because otherwise I just have to crawl up in a ball. I'm not even to the impacts yet. One last thing I will say. I love this slide from NOAA. Weather versus climate. Weather and climate are two different things, right? Weather, well, look around what everybody's wearing. We can guess what today's weather is, right? Nobody came in here with an umbrella. Nobody's in shorts and a t-shirt. It's not super hot out. We live in North Florida. Not many of us have snow boots and winter hats and whatnot. What you have in your closet, and if you live in Chicago, is different than what you have in your closet if you live in Honolulu, right? Because climate is a long-term thing. Weather is just what it happens to be doing today, and weather is all over the place all the time. But climate is pretty steady year to year, but climate is a long-term average of decades, hundreds of years. So just keep those two straight. All right, so let's do it. We ready for impacts? They're awful. What time is it? Okay. Woo. All right. So these are the 14 impacts I'm going to talk about. They're awful. They're in no particular order. They're all very interconnected. This is just how my brain sort of organizes them and puts them together, but I think you can look at it in many different ways. All right, so all this extra heat entering our atmosphere, where is it going? The vast majority of it is being absorbed by the ocean. 90% of the extra heat that the Earth has trapped is being absorbed by the ocean, because if you remember your chemistry, water has an incredibly high specific heat content and is able to absorb lots of heat energy. So the oceans are warming. This is a weird picture. The gray is the land. That's Florida, Texas, Mexico. We remember, right, in August, the news of record ocean temperatures. So what happens with all that extra heat? You have extra heat, you can make a bigger storm, right? You have to boil your water to cook pasta. You can't put pasta in cold water and expect it to cook, right? You need heat energy. Heat energy in the water makes a hurricane stronger. It doesn't necessarily make more hurricanes. They are not entirely sure what climate change is going to do with the number, but they are sure what's going to happen with the intensity and with the intensification. I don't know how many of you followed the hurricane that hit Acapulco. It intensified first of all, it was the first Cat 5 in the Pacific Basin ever. Second, it intensified in, I think, something like 18 hours from a tropical storm to a Cat 5, which is why so many people died. We know a lot about hurricanes here. Let's go to the Arctic. We got a lot to talk about. So this is kind of a weird picture. This is Russia, Norway, Sweden, Finland, Iceland, Greenland, Canada, Alaska. So we're looking down at the North Pole. The North Pole has no land, right? All the ice up there is floating. Well, that ice is melting, right? Because the oceans are warmer. The amount of ice is melting significantly, and yeah, it's probably going to cause polar bears to go extinct. It's probably going to cause walruses to go extinct. They need to rest on the ice. But beyond that awful statistic, it has serious consequences. What's happened in the Arctic has serious consequences for the entire planet. That's decreasing ice. I'll skip that. It's also decreasing the Antarctica is a continent. There's land down there, right? But there is floating ice around it. That's also decreasing. And let me jump back. One of the things I will say, one of the things causing so much melting in the Arctic is that there's a terrible feedback loop going. When the sun's energy hits ice is very bright and white, and it reflects energy away, right? Which is why my new roof is white, because it will reflect energy away. Well, as the water warms and the ice melts, you don't have that white thing there anymore. You have deep, dark ocean. And now when the sun's energy hits it, it absorbs that energy. So it melts more ice. So when the next radiation hits, there's even more deep, dark ocean. And it's this terrible feedback loop where the ice is melting faster than we would expect it. The Arctic is warming as much as 4 times faster than the rest of the planet. So that has an impact on winds. So every single planet that we have discovered in the universe has what are called polar vortex winds. At the poles, there are these super high, like stratospheric winds that spin crazy, crazy fast. And because it's so cold, they don't interact that much with the next pile of circulating winds. We call them the jet stream. So our jet stream and the North Pole polar vortex used to not interact with each other that much because their temperature differential was so great. Well, now that their temperatures are getting closer to each other, they're wobbling and mixing more. And so what's happening is the polar vortex winds are dipping down more. So climate change models predict that if you live in the mid-latitudes, which most of the US is mid-latitude, that you will have occasional dips of crazy cold sometimes in the winter, which is what Texas had when they had those crazy freezing temperatures. We've had some. Staying up in the Arctic, this is another kind of weird picture. Canada, Alaska, Russia, Greenland, Iceland. Because the Arctic is warming so much, the frozen land in the Arctic is thawing. And that's an infrastructure problem, like roads and gas lines and airports and whatnot and buildings. They're wobbling now because they were built into frozen land, but now the land is getting squishy as it melts. And so that's one problem. But the bigger problem is the permafrost land has trapped inside of it massive amounts of carbon, massive amounts, because the tiny little growing season that they have, stuff will grow and then stuff will die, and it can't rot. It's too cold to rot. The microbes don't rot it away, and so it just sits there. And then next year, same thing. And so it's all piled on. And it's piled on so heavy that now that it's warming and thawing and microbes are trying to rot it, oxygen can't penetrate. So there's not enough oxygen penetrating, helping this rot. So instead of it being aerobic respiration, it's anaerobic respiration. And so instead of emitting carbon dioxide, it's emitting methane. It's rotting in a more dangerous way, because if you remember from that chart, methane is a much stronger greenhouse gas. And so this is also a terrible feedback loop. As the permafrost thaws more methane is emitted. More methane, more warming. More thawing, more methane. More warming, more thawing. It's just not good. Glaciers. Any ice, let's go to the land a little bit now. Any ice sitting on the land is also melting. Pretty much every glacier on the planet is melting. Well, we'll go on. Some of that melting is causing a serious problem with the ocean. It's not just that when that water melts, it goes into the ocean and causes sea level rise. It's also the type of water. A melting glacier is fresh water. And the oceans have a massive overturning current that it's called the thermohaline circulation, thermohaline salt. So it's a temperature salt thing. I could take 20 minutes to explain it. I won't. But the bottom line is, because the ice on Greenland is melting so much and entering the ocean, it is slowing down this North Atlantic circulation. And that will have serious implications for the temperatures in Europe. But we can't get into it. Sea level rise. So this is one we care about a lot here, right? So thanks to all this melting, but really also thanks to the heat. It's not just extra water in the ocean, it's also that the ocean is hotter, because hotter water moves more and expands more, so the water's literally taking up more space, so the sea is rising. So since the Industrial Revolution, we've had 9 inches of sea level rise. With very high certainty, we will have 1 more foot of rise by 2050. I will still be alive. By the turn of the century, we will have 2 to 7 additional feet of rise. So think about this island. Think about Front Street. Think about Crane Island. Think about most of the marsh. Think about the beach and our dunes. This is Amelia Island. We've had a water level station downtown since 1897. The rate of rise, let me go back real quick. The rate of rise is accelerating, by the way. Just in the last 30 years, the rate of rise has doubled. Not good. How much will it rise? Again, depends on our choices. Will we just get, we are definitely getting another 2 feet of rise by the turn of the century. That's already baked in. There's already enough carbon in the atmosphere that it's going to warm up to that. Because the warming doesn't happen instantly. You don't put a blanket on and instantly warm. It builds. So how much rise we're going to get will depend on our emissions. I forgot to get the picture from John. The Front Street. Shoot. Okay, that's okay. John, next time I need your picture. Sunny day flooding. I'm sure we all live in Florida. A lot of you have probably heard of sunny day flooding. Flooding when there's not even a storm. In 2020 we had record sunny day flooding here. This is for Fernandina Beach, for down at Front Street. By the way, our flooding risk is way worse on the marsh side. Where's Frank? Our dunes are in pretty great shape for the most part, especially if we just let them do their job. But it's the marsh side that's our real problem. And on Nassau County, their marsh, on the mainland side, their marsh side. On the end of October, on the day of the Florida-Georgia game, it was gorgeous weather. It was a full moon, and John went down to take a picture, and there was flooding on Front Street. And nobody knows. It's not in the paper. You don't pay attention to it. Nobody goes down there per se. Day after Christmas, 8 o'clock in the morning, go down to Front Street. Put it in your calendar right now. It's a full moon on December 26th, and high tides at around 8 o'clock. And there will be flooding on Front Street. And what's going to happen 50 years from now with that flooding? What's going to happen to those businesses down there? What's going to happen to the train? What's going to happen to the port? What's going to happen to the factories? What's going to happen? Yeah. We all know Florida is among the most at-risk places on the planet. But there's a lot of at-risk places on the planet. 80% of the people in the world live close to the ocean. Pretty much every major city you can name is near the ocean. It's very rare that big cities are way inland up rivers and whatnot. Most of the big cities of the world are on the ocean. And they're all at risk of sea level rise. We're rich. We'll just up and move. Our homes are probably insured. What will the poor do? Which brings us to our next impact. They will be refugees. We already have climate refugees in the U.S. the U.S. government, our taxes, have already paid to move an entire island of people off in Louisiana and an entire village in Alaska. This is a low estimate. There's 89 million refugees in the world right now. And we know that's causing political strife all over the place, including here, right? By 2050, there's estimated to be 200 million climate refugees. And that's a low estimate. There's data out of Cornell University that it could be as many as 2 billion refugees by the turn of the century. All right, moving on with the bad news. Coral reefs, most of them will be destroyed because of heat, because of sea level rise. The sea rises, they need the sun, right? Because they're a symbiotic relationship with an algae that needs the sun. Ocean acidification, as this is a great graph. It's also a confusing graph. Red is rising carbon dioxide in the air. Green is rising carbon dioxide in the ocean, because if it's in the air, it will mix with the ocean. So there's more CO2 in the ocean. If you mix carbon dioxide with water, you make carbonic acid. You make an acid. That's what happens. That's why soda kind of burns inside your nose. That's the acid burning a little bit. So blue is pH. So the ocean is becoming more acidic. It has dropped significantly. This side is pH. It doesn't seem like a big drop if you look at these numbers, but if you remember your chemistry, pH is a logarithmic scale, so that's a 30% drop. The ocean has become 30% more acidic. And that's a really huge problem, because all the shelled organisms in the ocean, they're made of calcium carbonate, and calcium carbonate dissolves in acids. And the more acidic you make the ocean, the harder and harder it is for a shelled creature to make their shell. And, it's one thing walking on the beach and all the pretty whelks and everything. I'm not talking about them and the crabs so much. I'm talking about the tiny guys, the plankton and whatnot, and the krill that make up the base of the food chain in the ocean. If they can't make their shell, then what happens to the food chain in the ocean? It collapses, which leads us to the 6th great mass extinction, right? We are on the cusp of the 6th great mass extinction. Many people say we're no longer in the Holocene, we're in the Anthropocene. Thank you. We're in the Anthropocene. We're in the age of humans. And it is predicted that we will have a mass extinction. It will start in the ocean when tiny little krill can't form and whatnot. It will happen on the land as biomes shift, as food bases collapse, right? It's the base of the food chain. If the insects are already collapsing, right? If the base of the food chain collapses, then the top has nothing to eat. Which is why, by the way, you don't just plant as much as you can in your yard. Get rid of as much lawn as you can. Lawn is so useless. Plant as much as you can, but plant native, because we need our insects. And insects aren't hanging out on your non-native tropical plants. They're only hanging out on native plants. And if you want the stuff at the top, you need the stuff at the bottom. So moving on. Forest fires, super complex. Wow. Okay, I'm getting a signal that it's late. Forest fires, super complex because of how we fight fires also, but they are definitely getting bigger because it's drier. In many areas are experiencing drought, and then the fuel is drier and it burns hotter. Some places are not drier, some places are wetter. This is a measure of the top 1% of events. I'm talking stuff like Fort Lauderdale had in April, right? Fort Lauderdale had 26 inches of rain in one day. It's beyond comprehension. We don't even pay attention to the rest of the world, right? Pakistan, a third of the nation underwater when they had record monsoon. 2 million homes, 10% of GDP. I mean, it's incomprehensible numbers. Human health. Heat kills more people than any other natural event. Mosquitoes and ticks pretty much are psyched about global warming. Impacts on respiration, super serious, and mental health. And I'm not just talking about like me and like, woe is me, climate change. I'm talking about, your house got destroyed for the second time, or you have to flee someplace because you can't grow food. Lastly, impacts. This is the last impact. Agriculture. Nights are warming way faster than the days, and without a cold night, a lot of fruit won't set. A lot of fruit needs hardening off. A lot of flowers need a chilled night in order to set fruit in the first place. And of course, the pests. The pests love it. Some places, by the way, will benefit from the shifting climate. Like Canada might become the new breadbasket of the world, but they don't have the infrastructure, right? There's no big giant farms, and there are some, but not to where some of it's going to shift. It's an infrastructure thing. Oh, which brings me to another thing that I forgot to say, which is why I put the Earthrise picture up there. I always said to my students, we're not saving the Earth. We're saving the climate for how we like it. The Earth doesn't care what we're doing. The Earth has been in some crazy situations of molten lava. There was a snowball Earth period. There's ice ages. The seas have come up and down. The continents have moved. The Earth does not care. We're not saving the Earth. We're saving the climate as it has been for the last 10,000 years or so, because we built a super complex civilization and we need it to stay that way, because we can't just pick up our airports and move. But yeah, all right. So let me skip. Oh, does everybody know we switched zones? Yeah, did you get that news? Yeah, we no longer have any Zone 8 in Nassau County. So lastly, this is my last slide before we get to solutions. Congress mandates that all of these agencies put together a report every 4 years. They just came out with their new report a few weeks ago. Without deeper cuts in global net greenhouse gas emissions and accelerated adaptation efforts, severe climate risks to the U.S. will continue to grow. That's the thing about climate change. It will continue to get worse. It's bad. It'll be worse, and then worse again. It's frightening. So, what do? We do a lot, is what we do. The main thing we got to do is we have to stop burning fossil fuels. We have to get super close to net zero. Right now in Dubai, the UN Conference of the Parties, COP28, is taking place, and it is on the fence whether or not they are going to finally put the words in, phase out. They almost got it in the agreement 2 years ago in Glasgow, but they need to phase out fossil fuels. It's as simple as that. And the cool thing is, it's not like cancer, like, oh, this terrible thing that we wish we could cure, it's killing people and terrible, and darn it, we don't know how to cure it. It's not like that, because we do actually know how to deal with this. We still need energy, right? We need a lot of energy. We just can't get it from burning these things anymore, because we have to stop emitting so much carbon into the atmosphere. I will skip these and jump straight to here. This is global world emissions up till last year by sector, by power, building, transport, agriculture. We are not on track to reduce our emissions. We are supposed to reduce our emissions. This is in order to stay below 1.5 degrees of warming, we need to reduce our emissions by roughly half by 2030. That's, can I do math? 7 years from now? Half, reduce our emissions by half, and then get to carbon neutral or net zero by 2050. And we are not on track. We are actually not even close to on track right now. I'll just let you know. So we are still increasing. We had a blip of decrease during COVID in the world. But Margaret's right. I am perennial optimistic. Perennial optimistic. This is Germany. Germany is on track, right? Germany's super rich. We lived in Germany twice. My husband 4 times with the Army. Germany is top 20 nation in terms of population. Number 3 in terms of exports. And they are a huge industrial nation living a really high quality of life, and they are reducing their emissions, and they are on track to be net zero by 2050. Last year they had several days over the summer where 100% of their electricity was coming from solar and wind. Because, man, if you've been to Germany, solar's everywhere. You see it everywhere. You cross over to France and you don't see it anymore. It's just incredible. They're reducing everywhere. So, what do we personally need to do? These are the top 3 things you need to do. Forget recycling. No, don't forget recycling. You need to vote with climate change in mind. You need to write your elected officials. They need to know that you have their back when they go out on a limb with a risky proposition of building an electric car charging network in the county, right? They need to know that yes, that's what we want. And we need to talk about it, and we need to act. We don't talk about climate change because we think the person next to us is a climate change denier, and they're not mostly. And we also need to act. It is actually our actions that people will follow most. And we saw this in Maryland. We put solar on our roof in Maryland, and within a year or 2, it was everywhere in my neighborhood. They say within a half mile of a home that puts solar on their roof, solar increases by 50% in the neighborhood. So if you're sitting there thinking about going solar, because we're about to put solar on our roof, and it's not great numbers in Florida. In Maryland, it was great numbers. But there's way more energy. There's way more solar energy in terms of the sun in Florida. Do it because your neighbors will do it, and then you get an extra boost. It's almost 7, thanks. So Yale University does research on climate communication. More than 50% of Americans are concerned or alarmed. You all are here, which means you're somewhere up here. I'm hoping to push you all to alarmed. Because then you'll act, right? Probably you're already acting in various ways now, right? Very few people are hardcore deniers. This is one of their questions from their survey for Nassau County. Should we teach about global warming in the schools? Yeah, we should. Yeah, right? Your neighbor is not a climate change denier. Talk to them about climate change. Let them see all the things you're doing. Talk to them about the EV, car you're planning to buy and whatnot. The other thing we need to do is we need to have a mindset change about energy. 300 years ago when we had to wake up and go get water somewhere and go get firewood somewhere and then boom, the firewood all burned in 20 minutes and we had to go get more. We were more closely connected to our energy. Now we just flip switches and pay bills, and we're not as closely connected to our energy. But we need to recognize, like all the blueberries at Publix right now all came from Chile and Peru, right? There's no blueberries growing anywhere around here. That's a big carbon footprint to get them here. Should we be eating blueberries in the winter? It's a big carbon footprint. By the way, I'm not pointing any fingers. I live in a big house and drive a big car, and my Prius got totaled, and I'm waiting to buy a new. Our plan. I plan to never buy an internal combustion engine car again. Drink locally, right? Because if you drink a beer from Germany, it had to ship here. But if you drink one from Okama, your carbon footprint's way lower. Yeah, I'm serious. So So what's happening when we do stuff? When you burn a gallon of gas, you're emitting 20 pounds of carbon. A 4-ounce serving of beef. Yeah, beef gets a bad rap for a reason. A flight up to DC, and look at the tree. A mature tree, that's my yard, is only, I'll say only, absorbing 50 pounds of carbon a year. It's a lot. We should plant trees. There's probably baby oaks growing trying to pop up in your yard everywhere. Let some of them grow. Why should we reduce our beef consumption? Because it has a huge carbon footprint. You have to grow food to feed that animal, and then that animal's a ruminant. The way it digests its food, it's burping and farting methane, which we know is a very serious greenhouse gas. The awesome news is, it's good for your health to eat more vegetables, right? To eat more plants. It's good for our health and our wallet to do almost all of these things. There's a million things. I could have written 20,000 slides on things you could do. And by the way, no finger pointing. Everybody's on a continuum of climate action. And yes, we should all have some guilt. We are rich Americans and we have emitted more than pretty much anybody. But we can reduce our emissions. We can buy local. We can get that refrigerator out of the garage because it's using so much more energy to fight the heat. We can drive less, carpool, bike more, walk more. My hair is capable of bar shampoo. I'm not sure if yours is, but right, because we ship so much water around that takes a lot of energy to ship water around. Use cold water. My students all knew it, man, they better not come into my classroom with a bottled water. And if it was a bottle of water from Fiji that had to ship here from Fiji, really? Then they knew they were going to get stink eye. Plant as many trees as possible. Compost. Big stuff. Plan your next 10 years. Get solar. Get an electric car. Waste less energy in every way you can. That's our old house in Maryland. Recycling, yes, absolutely recycle. It costs money and it takes energy, but it costs less money and takes less energy than just trashing stuff. But the key to recycling, though, is did you need to use the thing in the first place, right? If we just use less, reduce comes first. Like, I'll challenge you for the holidays. Can you come as close as possible to a trash-free holiday? December 26th is the biggest trash collection day in America. And that's a big carbon footprint. Does that need to happen? I don't know. Composting is just off the charts amazing. Everybody should go eat at Townies because they run composting classes and they have that awesome garden and they have an EV charging station. Composting not only reduces truck miles because your garden waste didn't need to get trucked to the landfill. It also puts nutrients back in the soil, and one of those nutrients is carbon. It puts carbon back into the soil. It sequesters carbon back into the soil. Soil that is black, carbon is mostly black, right? Graphite pencil is pure carbon. Carbon is mostly blackish. Soot is mostly black. And then you put all that carbon back in the soil, and then plus it's better for everything that's growing around it. Absorbs more water for storms. Compost is a huge winner. Definitely start to compost. Governments, what do they need to do? They need to just do a ton. I'm looking at the clock. I'm going to blow through governments in like 2 minutes. Governments need to lead the way in helping us switch to renewables. Helping us be more efficient, electrifying everything, and stop letting us just pollute at random, right? They don't let us just dump lead and mercury into the atmosphere, into the water. Why are we allowed to just dump carbon into the atmosphere? We need a smart grid. This is U.S. electricity generation. This is wind, solar, and mostly hydroelectric. They are all increasing in the U.S. Not fast enough, though, but they are increasing. The awesome news, though, is there's massive amounts of solar energy. This is a graph of the amount of solar energy striking the Earth. And, you know, it's off the charts high in the southeast. It's not as high here because of our cloud cover. Statistic of the day, remember this one? This is the one thing you should remember. In 1 hour, enough solar energy hits the Earth to power the entire planet for a year. 1 hour. Enough solar energy to power us for a year. There is ridiculous amounts of free energy hitting our planet. I imagine a world where my grandchildren, where solar is on everything and it's practically free, and pollution, because by the way, if we stop burning fossil fuels, there'll just be a massive reduction in all sorts of other pollutants too, right? Yeah, it's exciting to me. Germany, look how green Germany is. They have terrible sun, and yet they're one of the world leaders in solar production because there's enough. Solar is about to explode because it is cheaper. Very poor places like Africa, in parts of Africa, sub-Saharan Africa, they're going to leapfrog over energy, just the way they did with phones. They didn't lay phone lines and have phones. They went straight to cell phones and satellites. They're going to leapfrog over, transporting energy around on lines, and they're going to go straight to solar in smaller areas. Wind is about to explode. The Inflation Reduction Act is awesome. It's going to get us almost there. It could get us as much as 40% of our reductions, but it's not enough. It's the biggest U.S. investment in climate reduction measures, but it's not enough yet. The EPA did just announce a few days ago a new rule to reduce methane, which is awesome. This would give us a 2% reduction. The Paris Agreement said we need to be below 1.5. The UN is meeting right now in Dubai, which is, fraught that they're meeting in an oil nation. But they did on the very first day do what they've never done. They not only voted the agenda in, which they've never voted the agenda in on the first day, they also voted in the Loss and Damage Fund, which they've been working on for 15 years, that the rich nations need to fork over some money to help the poor nations, because it's the poor nations didn't do all this emitting. It's the rich nations who did the emitting and causing climate change. And so when Pakistan has flooding, they don't have the money to help their people. They need the money. There's also a lot of other agreements that have already happened. That's the end. Whew. Anyway, it's awful, but it's exciting. We can do it. We really can do it. Look at all these people here, because if all of us act, we really can do it. I drive my family crazy when I'm at the grocery store and they ask, do you want a bag? And I'm like, no, and I'm really loud for the person behind me in line. No, I don't need a bag. The world needs fewer bags. And we once had a chef come out and thank us because she asked us if we needed a box for our to-go. We're like, no, we brought our boxes, right? Because we have Tupperware in all our cars. And bring our own boxes. Everywhere. I keep a spork in my purse so that if I happen to go eat somewhere, I don't need a fork, a plastic fork. Because single-use items are the enemy. And I always told my students, toilet paper. That's the only single-use item you should use. Otherwise, paper towels, never buy them again, right? Napkins, never buy them again. It can all be paper. But anyway. Does anybody have any questions? Whew. Yes.
Naomi and I work for the county.
Oh.
And because of Ann Colmeany, who is the resilience officer, or whatever they call her, in Jacksonville, we got Nassau County participated with a bunch of other municipalities in the Northeast region of Florida in a greenhouse gas inventory inventory of the county, the emissions the county government buildings and fleet emit, and that was, we completed a report, and now the next thing is to apply for this, climate pollution reduction grant
Awesome.
as like a region, so I just want you to know.
Awesome. Did you hear that? That they did that the county worked with the city of Jacksonville and the region to do an audit of county emissions in terms of the government emissions, government buildings, the government fleet, of what are the buildings, what are we emitting?
You know, whatever produces emissions.
Because you have to know your baseline. What are we emitting now? And by the way, you can't apply for any grants until you know your emissions. And so then now they're applying for grants to reduce their emissions. Yeah, that's awesome. That's awesome. Yes.
So I love all your individual suggestions. I have heard and read in several different places, though, that what each person does, each individual, really is a tiny drop in the bucket. I might have heard it from you.
Yeah, you did.
But,
You did.
But my question is, how would you answer when somebody brings that up? What would you say to them?
That's a great question. You know, your own individual emission. Our own individual emission is squat, right? There's 8 billion people on the planet. What you do personally is meaningless, right? Go fly to Hawaii every single day. No, because it's not. And it's not if other people see you act. They talk about your carbon footprint being like the bad things you're doing, all your emissions. They also talk about your carbon handprint. What do you spread? What good do you spread? What do people see you act? And people will act. There actually was an article in the Washington Post yesterday. The best thing you can do for climate change is act. And it was the number one thing that got people to change, was not showing them all the data, but watching you get your EV and put your solar on and bring Tupperware and turn your change your temperature, in your house and put more insulation. And because if you look at how many people are in this room. If every, it's like that old Breck's hair commercial, and then she told 2 people, and then she told 2 people, right? Like if you spread the word if 10 people act on things you're acting on, then suddenly your impact is huge, starts to become huge.
Action is a force multiplier.
Yes, I love that. I'm stealing that. Yes, action is a force multiplier. Yes, good one. Yeah. Yes.
Does your sea level rise graphs take into effect glacier melting, like in Antarctica?
Yes. That's a good question. No. Western Antarctica is a big long finger that is pointing toward the tip of South America, and it's like a peninsula like Florida. It's surrounded by water. It's very impacted by the water temperature, and as that water is warming, it's warming more than the rest of Antarctica. Antarctica's land, there's ice sitting on top of it. There's a mile of ice sitting on top of Antarctica. They do these huge cores through the ice to measure all sorts of things. But one of the huge fears is that so much of that sea ice around Western Antarctica is melting that it's going to cause collapse of the glaciers in Western Antarctica, because the sea ice is kind of acting like a stopper. It's kind of pushing on the, because glaciers move, right? They're always sliding down, and they're sliding toward the ocean, but the ocean ice is in the way. And yeah, if that ice melts, if Greenland's way smaller. If Greenland melts, Greenland's got, let me not get it wrong, Greenland's got, I think, 10 meters of sea level rise in it. Western Antarctica, we're talking hundreds of feet. Yeah, we're talking the future as we know it will be utterly different. And that's, by the way, what they talk about when they talk about tipping points. And that's why the Paris Agreement set 1.5 degrees Celsius, because of tipping points. Like I can push on my laptop, and I can push and push and push and push and push, but there will come a point where that same push causes a tipping point and the thing falls over and crashes, right? And scientists are very concerned about tipping points. That are we going to reach a point where the glaciers on Antarctica or Greenland are going to melt no matter what we do? And if that happens, then we're really in trouble. Yeah.
Yeah, the analogy that they make is that all of it's like a battleship. It won't turn around quickly.
Yeah, exactly. I won't be able to sleep tonight. Mark, my neighbor.
Joyce, neighbor. What do you say to people that have, when you try to talk to them about climate change,
And by people, do you mean climate change deniers? Is that what you're getting at?
if you'd like to refer to them as such, I could refer to them as my siblings. But what do you say when they say things like, well, Michigan used to be covered in glaciers and, climate just changes. And
Yeah.
It's cyclical.
Yeah.
right?
It's never changed this fast, you could say. It's never changed this fast, except for when the dinosaurs went extinct. When the meteor hit.
So that's the best you got.
Well, no. I mean, actually, according to Yale and the climate communication, they mostly say that you should ignore hardcore deniers. That seriously, that there's literally nothing you can do. Where's that? Where's that slide? This one. That it's really these people you want to talk to. These people you can talk to, and we can push them to being more concerned. These numbers in the U.S. have not changed hardly at all. These two have hardly changed at all in the last 20 years since they've been doing this research. These numbers have changed significantly. Because these people, they just belong to their camp and they're not going to pay attention to, you literally can't say anything to them. Your efforts are better off here. Okay. Yes. 7:16. We have to be out of here and lights out in 14 minutes. Let's do it.